Hi, and welcome to the Mobile Apps in Trouble webinar. In this webinar, we'll share with you some tools and techniques that we use when debugging and troubleshooting mobile apps in OutSystems 10. My name is Daniel, and I'm the captain of the apps team at the OutSystems engineering department. I've been working for OutSystems for 4.5 years and joined the apps team in late 2015 when OutSystems 10 was in its early alpha versions. My team has been making mobile apps in OutSystems 10 since even before I joined, and we found that the main thing newcomers struggle with is debugging and troubleshooting. This motivated me to share some of the experience we've been collecting in hopes that you will find it useful as well. So I'll start with a short introduction, and then I will highlight the main differences between making mobile apps now and before OutSystems 10. I will then do an overview of the tools we use in the process, as well as some tricks and advice that I believe are important. Then I will do a live troubleshooting session where I will identify and fix a few common issues and show you the tools in action. Once that's done, I will do a short recap and go into the questions and answer session. So, for an introduction, let's consider what we expect from mobile apps. And I'll start by sharing some numbers that I found. These days, there are over 6 million mobile apps available in stores, which amount to 179 billion downloads a year. More than half of those have a 5-star rating. So if we consider the sheer size of the mobile app market, the millions of apps competing for attention, and the very high quality of most apps, while they're free and have very low prices, it's no wonder that mobile app users are getting pickier, more demanding, impatient, and willing to drop an unsatisfying app at a moment's notice. I know I am one of those users, and maybe you are. And I have, even if unconsciously, set my bar really high. I'm not at all surprised that users have come to expect apps to have a great user experience, great performance, a very cool, sleek-looking user interface, and no bugs. And the list goes on. I mean, great is now the new normal. So what can we do to make our apps great? We need to understand how they work and what you can do when they don't. Also, it's no surprise that the issues we come across in app development tend to fall within these very same areas. UI, we often run into flickers and animation issues. Responsiveness issues like slow reaction to user actions or no visual feedback. Performance issues like slow transitions, long time to first screen render, or frame rate drops. Also network issues, poor connection, offline sync issues leading to inconsistent data. Now a little bit about mobile apps in OutSystems. Mobile apps in OutSystems are hybrid web apps. This means we have a backend server hosting the app's code, resources, and data, and then we have a thin native shell that runs on mobile devices. This shell acts as a browser, and it provides access to native device functionalities. This hasn't changed in OutSystems 10, but there's a few things that did change. For example, user experience. Before, we were making mobile screens using responsive layouts, just like we were doing web screens. In OutSystems 10, we have dedicated mobile UI patterns and a true mobile experience with animations and screen transitions out of the box. Before, our screen refresh was specifically triggered and involved retrieving data and UI from the server. In OutSystems 10, we have optimized this process for mobile, so the app logic and UI can run on the device, so we only need to call the server to get data. Also, before we had no offline capabilities out of the box. We had to use third-party components for that. With OutSystems 10, we have local storage for offline data. The app code is also stored offline, and we can easily run logic on the device. As far as deployments and updates are concerned, before, code and resources were always retrieved from the server. With OutSystems 10, code and resources are stored locally for speed and to provide standalone capabilities, but they get automatically updated when changes are detected. Also in OutSystems 10, we have a completely new runtime. And the key aspects to remember about this runtime is that it's built to respond quickly and automatically to data changes. This allows mobile apps, which are still hybrid behind the scenes, to feel more native by reducing the time to the first screen render, reducing communication with the server, and by making it easier to build logic that runs on the client side. Also, the generated code is based on the model view controller architecture. I won't go into too many details about what this standard is, but I'll just let you know that each screen has 3 JavaScript files: the model, where you have the screen's data; the controller, where you have the screen's action and events; and the view, which has the widget's rendering code. Each UI flow has a controller that has the exception handler for that flow, and each module has 4 files: the controller, where you find the global client actions; the entities, where the SQL code exists that manipulates the local entities; the model, that has the local entities themselves; and language resources. Now, while troubleshooting, we're mostly looking at the controller because that's what contains our screen actions, and the module controller that contains the global actions. For the most part, we don't need to look at all the other files. Also in OutSystems 10, there's a whole new page lifecycle. It's very important to get familiar with this lifecycle. And the way this works is, before the screen's DOM is loaded, the platform fires the initialize event, which you can use to initialize variables and do short calculations that you will need to render the first screen state. It's very important to keep this processing short. After this event, the DOM starts getting loaded, and screen aggregates and data actions are fired in parallel. As soon as the DOM is loaded, the ready event fires to indicate you can now interact with the DOM if you wish. The render event is fired right after and will be fired again every time there is a change in the screen state. Also, as aggregates and data actions return, the respective after fetch events are triggered, and you can use them to manipulate the data that they return. Also important is to understand what goes on during screen transitions. When a navigation action is triggered, the destination screen starts going through its life cycle outside the viewport, invisible to the user. It's only after the ready and the first render events get triggered and the first screen state is rendered that the animated transition starts, as you can see here. Once the transition ends and the previous screen is invisible, its DOM gets destroyed and the destroy event is fired. Then the new screen continues its life cycle independently. Now I'll go over a little bit about the troubleshooting tools that we use. I won't go into too much detail for now. Chrome Developer Tools is our main workhorse. Now, OutSystems 12 mobile apps will run in Chrome or Safari as a fallback. They're really designed to run inside the native shell that I mentioned earlier. But these two browsers provide a fallback that's very helpful to accelerate debugging and troubleshooting. So I use Chrome Developer Tools because I own a PC, but you can use the Safari Web Inspector in pretty much the same way. Anyone familiar with web development has likely used Chrome DevTools before, but I'll do a quick overview nonetheless. To start using Chrome, just point your browser to your app's entry point, hit F12, and you're good to go. Now, this view, the DOM elements view, I use it to troubleshoot styling and layout issues. You can see here on the left a tree representation of the entire DOM. And then if you select an element, you see on the right-hand side the style breakdown for this element. You can see all the classes applied, all the styling. And you also have some very useful other features on the right-hand side, like you can check event listeners, you can see the elements properties, you can even set breakpoints on DOM modifications. So go to this view whenever you need to troubleshoot some sort of layout or styling issue. The JavaScript console tab, I go to this to troubleshoot JavaScript code basically, and to view the content of the output stream. I can see the console logs and the console errors here. And I can also run JavaScript code in this prompt. This is useful if I want to check the value of some variable or call an action at runtime. There's also the sources tab. Here you can see pretty much all the source files that make up your application. On the left-hand side, you'll see all the files. That includes JavaScript, it includes CSS. In the center pane, you see the code for the file that you have selected. And then on the right-hand side, you have the controls for the debugger, and you can see the breakpoints that you set. You can inspect variables and do all that. So this really useful view to troubleshoot JavaScript code as well. The network view. Now, this view is used to troubleshoot your data flow. So data retrieval, either from local cache or from the server, will be visible here. You can see the sequence of requests. You can see how long they take. You can see this is how long they take. You can see if they're coming from cache or if they're actually being downloaded. You can see the status. You can even dig into the response data. And you can also use this for simulating network conditions. You can use throttling. You can simulate an offline scenario. So really useful view. I use it always when I want to see what's going on with my data exchange. The timeline view. This is not a view that I go into when I start troubleshooting. It's not my first go-to tool, but it's very useful to get a global picture of everything your app is doing. So if there is a scenario that you're a little bit lost, you've tried other approaches and you don't know what's going on, using this tool will usually provide you with a good bird's eye view of everything that's going on. It will allow you to identify performance bottlenecks and drill down in those problem spots. The application view. Now, this is really useful to examine local data. Like I said, mobile apps in OutSystems 10 have local storage, local entities, and you can go to this view in Chrome DevTools to see the contents of the tables. You can check the contents of cookies, and you can actually even run SQL queries over the local storage entities. Another very useful feature is device simulation. This is very good to see your screens in a form factor that is similar to mobile devices. It has a few presets, like I'm using iPhone 6 here. But not only, actually the experience becomes more native when you turn on this device simulation. The scrolling becomes more like what you would expect from a mobile app. You will also see touch events getting fired. You can simulate geolocation and device orientation. So this is a feature that I pretty much have turned on all the time when I'm doing mobile app troubleshooting on the browser. Now, one thing that is very important to mention is that you can use Chrome DevTools not only to troubleshoot your application in the browser, you can actually troubleshoot while it's running on your device. You will need to connect your device to the PC, usually using a USB cable. And then if you have it set up in the right way, you will see, if you go to the Chrome //inspect tab, your device will be here, and you will see at least this entry for your app. Now, this entry relates to the web view, which is what is running your OutSystems code. I'm also using a plugin called Stetho that's available on the OutSystems Forge that allows you to do the same for the native shell as well. Now, this becomes really useful when you want to inspect the local storage on your device. Because local storage is a native feature, you won't be able to look at it if you're just inspecting the web view, okay? Another very useful plugin that you can find in the OutSystems Forge is the console log plugin. This is basically a screen that pops up and shows you the JavaScript output stream on the device so that you can see what's going on without having to connect your device to the PC. There's also other tools and tricks that I'd like to share with you. One of them is a recommendation to wrap your plugin calls, your native plugin calls, in client-side actions. These wrappers can check if the plugin is present, and if it is present, you can go ahead and call it and then return what you receive from the plugin. If it's not present, you can return something that is useful for the scenario you're troubleshooting. It could be an error value if you want to test your error handling code, or it could be some mock data if you want to test the normal flow of the application. This will help you keep your app in a state that it will always run in the browser. Otherwise, you might run into conditions where you start getting some JavaScript errors that Cordova is not present, and that will make it harder for you to troubleshoot. Another piece of advice is do use the JavaScript language commands to log information, to set breakpoints. There's nothing wrong with that, but I would advise you to do it in a clever way. So instead of just using straight up JavaScript nodes everywhere, also wrap these inside client actions. You can use these not only for reusability, but also to log additional info like severity here, or even feed a separate logging system. This is an example of such a logging system. It's a simple client-side persistent logging system that I built for this example. If you use the device log action from the previous slide, all the messages you log are also logged to local storage, and including the log message, the severity, and the time of the log. And the good thing about this logging system is that it's going to work all the time, even if you're offline. And I also added a feature that allows users to upload their logs for analysis. This is really useful if you distribute your app into the wild and someone experiences an issue that's a little bit of a freak event. It doesn't happen often. You can always get in touch with this user, ask him to access the screen, upload their logs, and then you can, if you instrumented the app enough, you'll be able to follow what happened and try to reproduce on your end. And last but not least, code review. It's important to not understate the value of this tool. Just by looking at the code and following through, you will find a lot of the issues that you're searching for. And even more powerful if you do it with someone else, peer code review. More often than not, just by explaining the problem, you find a response. This happened to me a lot of times. And if you don't have anyone available, use the rubber duck, the rubber ducking method. Just talk to your screen or talk to your cell phone, explain the problem, and you will actually get that eureka moment and immediately find out what's wrong. All right, now I'm going to do a quick demo where I'll go through a few common scenarios and show you the tools in action. For this, I have rigged a clone of the directory application. This is an application that's available on the Forge, minus the bugs. I put them there just for this demo. What is this app? It's an app that's offline first, so it's built on top of local storage entities, and there's a synchronization process that gets the data from the server and populates these entities. The data source has around 80 employees, and the main screen is the list of those employees, this one. There's also a search functionality. As you tap one of the employees, you go into the details screen. From here, you can check the employee's details, and you can also get in touch with him in a few different ways. And there's also the user profile photo, the user profile screen, where you can change your profile picture, you can set your location, and you can actually log out of the application. For my first scenario, I'm going to look at an element flicker. Now, you can see in this video that every time we type a letter in the search, there's a flicker to this image with two people. This is the blank slate. What usually happens in these situations is you have some very rapid screen state change. So some piece of data is changing really rapidly, and because the screen is automatically reacting to these changes, you actually see that that middle point that you don't want to show to the user. So first of all, what I would do is try to reproduce in the browser. I think this is always the best way to start. I'm going to log into the app here, and I'm going to try to reproduce the scenario. There you go. Very easy to reproduce. It's clear that this is happening. The way I would start looking at an issue like this would be to go to the code and check the conditional logic that is determining what's visible on the screen. However, today I'm going to take a quick detour just to show you how you could break execution at the moment we are doing this search. Now, I'm going to go to the Sources tab, and I'm going to find the controller for this screen. I'll just type employee lists dot controller. There you go. I will prettify the code, okay, And now, because I want to set a breakpoint on the change event for this input, which is when the problem happens, I'll just do a quick search for on change. There you go. And now I could set a breakpoint anywhere here. And next time I do a search, it's going to stop there. So this is what I want. And what I'm also going to mention is there's a very cool platform feature that's actually spelled out here in the code. If you have Chrome DevTools open and you have the control key pressed when you do your action, the execution will break automatically into the code. And also, once you release the debugger, it'll open Service Studio on the action that you are running. Okay. So I'm not going to show you that right now. The real way that I would troubleshoot this problem is just by looking at the conditional logic, like I said. So let me open Service Studio. And this is the screen that we want to see, employee list. We can see here the blank slate. We can see the list. And I will open the widget tree. And I can see the conditional here that's deciding whether to show the employee table wrapper or the blank slate. If I look at this condition, I can see that we're checking if the data is fetched and the list has some results. While this sounds reasonable, if we look at the change handler for the input, this one, and the handler is search keyword on change. So I'm going to open that action, and I can see that it's doing a refresh on the screen aggregate. This is exactly what we would expect from a search functionality like this, but this is this is exactly what's causing our problem, because what I'm saying is if the data is fetched and you have employees, then show the list. But when I'm refreshing the aggregate, this Boolean is going to go to false and make my condition false as well. What I'm doing is I'm using is data fetched wrong. This is not what I should be using it for. I could use it in a real life scenario to show a spinner or to update the user in any other way that we're actually fetching data, especially if it's a long operation. Because in this situation, it's a very short operation, it just flickers through a state that we don't want to. How to fix this problem? If I just remove this part of the condition and just check whether the list has any elements in it, we could also have the same problem, because when we are getting the new data, the list would be empty, and you would see the flicker in the same way. Now, the good thing is the platform has optimized this widget for usability, and what's going to happen is if you want to know if data is being fetched, then you use is data fetched. But the list itself will keep the elements that it had until it gets the new ones. So this fix should actually work. I'm just going to publish. And while this is publishing, I'm just going to mention a few other scenarios in which you can get flickers. And that's when, actually, it finished publishing, so I'll get into that a little bit later. I'm going to go back to the app. I'm going to refresh it. This would happen automatically during navigation, but I'm just doing it this way to be quicker. So now, if I search, the behavior is way better. Now, it's important to notice that what the platform is doing for us, regarding the list widget is what you sometimes need to do manually. If your data is going to pass through a state that you don't want to show, using some sort of buffer variable to keep the previous state visible while you're getting the new one is a perfectly valid approach, and it's exactly what the platform is doing for us behind the scenes. So this issue is fixed. We're off to a good start. What are the key takeaways? If you have an element flicker, you should analyze the conditional logic, the timing of aggregates, data actions, because when they return, if you didn't save the previous state, you might go through an intermediate state that you don't want to show. You can use buffer data during the transitions to keep them smooth. Also avoid showing, oh, this is the part I didn't go into, so I'll go into it now. There's a couple of other situations where you get flickers. Like, for example, if you load the first state for a screen, and then you run some calculations based on the DOM that affect this element style, if the calculations take a little bit long, you will see the element rendered in a way that you don't want it to. Also, if you have screen CSS and the CSS takes a little bit longer to load or process, which could happen in slower devices sometimes, it could also be rendered in a way that you don't want for a brief period of time. And there's a few things that we can do to avoid it. One of them is to avoid showing elements before the style calculations are done. You can either show a placeholder for it or a spinner. Depends really on your specific situation. And as far as the CSS load time, if you're running into those issues, you might consider keeping your CSS in the theme to keep it loaded during transitions. If you do that, use selectors that are specific to that screen to prevent overrides from applying in other screens, which you wouldn't want. All right, let's step into issue number 2. In this case, we have a slow transition from the employee detail to the employee detail screen. However, if we go into the profile screen, it's really fast. We can see in the video that it does take a while since we touch the record until you get to detail. So, like I said, let's check if this happens in the browser. It's always a good place to start. So, I'm back in my browser, and I'm going to tap a record. It was actually pretty fast. I'm going to go to the profile, also pretty fast. Okay, it's clear I'm not going to be able to reproduce this on my browser. So let's see if I can reproduce it on my cell phone. In order to do that, what I'm going to do is, like I showed you previously, I'm going to open Chrome ://inspect, see the list of connected devices. And my device should show up pretty soon. Oh, sorry, actually, I can't do this on this window. I'll open a new window. Okay. Chrome ://inspect. I was in a private mode window, and I can't inspect my device on a window in private mode. So this is a normal window now, and I'm going to inspect the web view. I'm not interested in looking at the local storage right now. I just want to see this happening. So I'm going to turn on the screencast so that we all can see my screen. and I am going to tap one of the employees. Okay, there you have it. This did take a long time. Now, first piece of information, this only happens on my mobile device. This, after a while of doing this, you start to get a gut feeling of what's going on. And if I go to the code with, this gut feeling, I might find the problem right away. But I want to show you the timeline tool that I mentioned earlier. This is one of those situations because it's related to timing, and it might be that looking at the timeline during this transition might help us go into the code with a little bit more information. So the way this works is I start the recording over here, I run my scenario, and then I stop it as soon as possible because this collects a lot of data, and the longer you run the capture, the more confusing it's going to be for you. And so, keeping it short is always a good idea. So I start the recording, I tap an employee, and I'm seeing this only on my screen. My apologies for that. It stopped. And now we have the timeline. Now, it would take almost an entire webinar to go through all the things that we should know about the timeline. But in this case, there is something that is very clear. From the time that I tapped the employee until we actually got to see something happen over here and got to see the new screen, there's a big blank space that takes 2 seconds, 2.5 seconds, 2 seconds. This is a very good hint, but let me just take a little bit of time to just share a little bit what we're seeing here. On the top, we're seeing the frame rate. We can see that from the moment I touch until we actually fire off some request, we're getting a lot of frames. We're getting a lot of frames rendered. This is likely the animation from my touch, so it's the feedback to my touch. And then we just don't do anything for a while, and then it starts again. Oh, sorry, didn't mean to do that. You can also see on the middle row the CPU activity, so it's completely idle, my application. There's no network activity as well, which is what we see on the last row. Now, idleness usually indicates a wait. So if we put this together with the previous information, we're waiting for something that only happens in the mobile device. I'm starting to get pretty sure there's some sort of native plugin call that's delaying my screen. So at this time, let's look at the code. If I look at, remember the life cycle, we're only going to do the transition after the destination screen has rendered its first state. So if the transition is taking a long time, it's really likely that we're taking too long to render the first screen on the destination. So the destination is the employee detail. I'll just open it up and see what we have here. Actually, we have some actions related to contacts. I wonder if I'm using the contact plugin anywhere here. So I'm going to go to where I have my plugin wrappers. All right. For example, find contacts. Sounds like something I might be doing on that screen. And actually, yes, I am. So in this screen action, check contact, I'm first seeing if the contact exists. I'm searching by mobile phone. And then if he does exist, then I'm setting this contact already added variable to eventually, yeah, there you go, decide whether to show this link to add contacts or a forbidden sign, meaning that I can't do anything because my contact's already added. Okay, good hint. Let me see where I'm calling this. I'm going to find usages again. All right. It's being called on initialize. Okay. Now I'm starting to get somewhere. Like I said, on initialize event handlers should do as little as possible because the DOM is only going to start getting loaded after this finishes. Okay. So if I have a plugin call that's taking 2 to 3 seconds, I should never do it on initialize. I will remove it from here, place it on the onReady event, and see if this solves my problem. So, transition issues. It's always, pardon me, it's always something related to how long it's taking to bootstrap the screen that you're navigating to. Actually, this finished publishing, so let me go really quickly to the inspect tab. We can see the application is here available to inspect. I'm going to do that. The problem is only happening on my mobile phone, so it's the way I need to troubleshoot it. I'm going to tap one of these employees to see if the problem is still happening. No, changed pretty much instantaneously. However, if you noticed, if you didn't, I'm just going to do it again. I have already added Anne to my contact list on the phone. So you'll see I can add her, and then I can. This is not necessarily a very good user experience. I'm just mentioning this because in some situations, if the operation that you're checking to see whether the user can do it or not, if that operation is sensitive, if it's something that the user cannot do over and over again, you might want to protect this in a different way. I'm not going to do that now because we don't have time, and also because trying to add the contact multiple times is actually harmless. So we can consider this issue solved, and that's 2 for 2, and I'm going to go back to the presentation. So what did we learn? We need to keep costly operations out of the uninitialized event handler. Operations that take a long time but don't consume any app resources usually indicate that you're waiting for something. That's going to be usually data, like aggregates or data actions, or waiting for native operations, plugins. The timeline is a good place to go to get a bird's eye view of what's going on. Like I said, not the first go-to tool because of the amount of data that it collects, but if you get stuck otherwise, it's a good place. All right, so moving on to issue number 3, missing data. We get a call from Abraham, print, he's not on the employee list. Everything else is working fine. The application is working fine for him, but it just doesn't show up. We can see here in the video that that's definitely true. Searching for Abraham isn't turning up any results. So I'm going to go once again to my application, to my browser, and I will see if I can reproduce. It should be simple enough. Actually, because these are alphabetically ordered, I can already see he's not here, but I'll search anyway. Yes, Abraham's not here. So the way I would start troubleshooting this is to see if he's actually on my main source of data. I like to use this cool feature from the platform that allows me to see what's inside the entities in this very simple way, to view data. I can filter here. Now the employee table doesn't have the employees' names. We have that on the user table, but we do have the employee's Skype ID, so I'll use that. Abraham. Okay, he's here. Now, if he's on the server entity, the next logical step would be, obviously it's not showing on my application, so let's see if he's on the local storage tables, because this information needs to get synced to the local storage in order to be visible on the screens, because this is an offline first application. I could inspect it right here, but I want to show you something which is the Stetho plugin at work. So I will go the long way. I will inspect my application on the device, and just to make an example, you could continue to debug in Chrome. Sorry, I made the same mistake. Let me fix it really quickly. Chrome inspect. Okay. So like I said, Stetho, the plugin, allows me to inspect the native shell and therefore the local storage. So we can see here, just like in Chrome, we have a web SQL section, and then under your application key, you have all your local storage entities. It's really quick to actually check if I have Abraham here. I can just sort, and I can easily see Abraham is right there. Okay, it's starting to get a little bit weird. At this point, I would just take a look at the code. Why am I taking a look at the code? Because there's probably something wrong with my query, because the data is there. If I go to the employee list and I look at the get employees screen aggregate, I'll start by checking the filters, checking if the employee is active and if the name matches the search keyword, not just the name, a few other fields. That looks good to me. Let's go to the sources. Okay. Now here we see we're getting the employee and their picture, which makes perfect sense for this screen. However, we're saying that we only want employees that have a local employee picture. This might be the problem. So I'm going to show you one way that you could actually check if this is the real cause. I'm going to go back to my inspector. And remember, this is my device. I have a query prepared. And this query is basically the same that we're running in that local screen aggregate. I'm checking for employees using an inner join, which is the only with. I'm joining with pictures, and I'm seeing if I get an employee where that's called Abraham. Okay, I get no results. That's good. Or actually, that's bad, but it's good for this example. Now, I'm going to do the query in a slightly different way, just to confirm my theory. I'm going to do the query. It's exactly the same query, except instead of doing an inner join, I'm doing a left join, which is basically the same as doing an aggregate. It says with or without picture. Okay, now we're getting somewhere. I do have Abraham on my database, but it doesn't have a picture. You can see all data related to picture is missing. Now, obviously, this could be a problem with the actual data that's on the server. Maybe Abraham just forgot to put his picture there, and that's a fair guess. But our application should not have a problem with that. I mean, just because the user doesn't have a photo doesn't mean he shouldn't be present. So the fix in this situation is a simple change to with or without, or at least I'm hoping that's what the fix is. My expectation is if this works, he will show up on the screen, but he won't have a picture. Let's see if that's true. Okay, publish is finished. I'm going to refresh the app. All right, we got the new code. And there he is. Abraham is finally here, but with no picture. All right, it's another problem fixed. What did we learn in this situation? Data is missing. There's a lot of possible causes for this kind of issues, and they usually depend a lot on the business scenario that you have implemented. But some general pointers would be start by checking the master data source. If the data is there, you can check local storage data using Stetho to inspect data on the device if needed. You can also code review to see if your sync process is correct or troubleshoot it. And if all of that seems right, then look at the application queries, because there's likely some sort of join condition that's preventing your data from being retrieved. Okay, I hope you're not getting too tired. We have one more. And in this one, we just get a complaint from a customer that they can't see any data in the app. Now, there's no errors in the daily sync, and it works fine on your device. I mean, it's what everyone says. I know I've said it a lot of times. But in this case, it's true. We've been using the app for the last 45 minutes or 20 minutes. And we haven't seen this issue. So the first step would be talk to this user, try to understand what's special about his case. Is it his device? Is it his particular user? In this situation, after talking to him for a little bit, you realize that he's been logging in with very poor network connection. These issues are, generally missing data issues are a problem to troubleshoot if you can't reproduce. So it's good to instrument your app in a way that you collect logging. Using a logging system like the one I mentioned before when I was talking about tools might actually help you in situations like this. But for now, let's just try to reproduce. I'm going to go back to the application. And how can I reproduce poor network conditions? I mentioned that in the network tab, you can simulate bad network conditions. You can go here to the throttling section, and you can pick from a bunch of presets. I like this one because it's quite extreme. It's not the worst, but it's the worst that you can expect to see in people's phones these days. And what I'm going to do is I'm going to use a debug feature that we built into this app, which is the refresh local storage. This allows us to clean all the data and start fresh, just like this user is. Okay, so you'll notice that I'm clearing the network trace just so that I can see what's going on. So I'm going to do this, and we're actually starting to see something happening here. If you look at this request, it took a long time to finish, and then it stopped after around 10 seconds. First, another thing we could already check. Well, first let's see if something happened. It did, yes. I have a completely empty screen. I go to my profile, there's nothing there either. So I definitely reproduced the customer's issue. We're missing data, so a clever next step would be to check what the local storage is like. And quickly, I find out that every single local storage table is empty, or at least the applicational ones. Now, remember, this app works offline, so almost all the data is retrieved from local storage. So if you don't have the data in local storage, then of course your application is going to be empty. The next thing I would check is, do we have any errors in the log? Actually, if I go here, yes, there is a very obvious error that stands out. There's a timeout here on the get employees action. Okay, starting to become pretty clear. We were able to reproduce. That was a good thing. Now, what if we hadn't? I mentioned the persistent logging system, and I'm just going to show you what you can get if you implement something like that. I rigged this application to bring up the persistent logging on a long touch, so I'm going to do that. Bear with me. Hope this works. Right, there you go. So what I can see is that when I went into the application with bad network, I have a couple of messages here that would send me in the right direction right away, even if I wasn't able to reproduce. Starting offline sync, there was an error, the connection timed out, and then we get this information that we're redirecting to the login screen. If your user had gone into this situation and you weren't able to reproduce, you could just call him and say, you know, long press on the screen and just hit the upload button. This upload button would just send all this logging information to the server so that your team could check what's going on and give you the ability to remotely troubleshoot this customer's problem. Okay. Now, we know exactly what happened. I'll actually take you to the code. I mean, we've seen in three different places that there's an operation that's taking a very long time. If I go to the offline sync code, get data, this action is the one that's taking a very long time. Okay, it's using the module default timeout, and the module default timeout is 10 seconds, which is pretty much a perfect match for how long we saw the request going for, pardon me. And we don't have an exception handler in this flow, which means that if this action throws an exception, we won't get to the point where we actually create all the local storage data. You can see here the device logs that I had put in my application beforehand, and I strongly advise you that if you're distributing an application into the world, or at least during the test stages, you might not want to keep this on in production. Do instrument your application in this way. Like I said, the timeout is firing. I'm not catching the exception, and so what's going to happen is the offline sync mechanism that is implemented by default when you bootstrap an OutSystems app is actually going to fire an event. And in our case, we're doing the synchronization in the splash screen. And the event that's going to get fired is on-sync error. This handler is pretty bad because all I'm doing is I'm checking if I have a user, this means the user is logged in, I'm sending him to the employee list. Otherwise, I'm sending him back to the login. Both of these destinations are bad. Employee list is bad because he's going to have no data. Sending him back to the login is also bad because he's going to just try again. Actually, he's going to do the login. We're not going to sync again, and then he's going to go to the empty employee list. So while we know the root cause of the problem, there's a number of things we would need to fix. We have a lot of data to sync, including photos, which takes a while to transfer over slow networks. The transfer is timing out and causing the entire sync process to fail. Also, when this happens, we don't provide any feedback to the user, and we allow him to go into the app with no data to show. What I would do here is actually split the sync process into chunks. I would first load a minimal set of data, maybe 5 to 10 employees, go into the employee screen, into the employee list screen and then sync the rest of the data in the background. We could also increase the timeout for that particular action. We can easily do that just by editing this value. I mean, if I set it to 60 seconds, this would probably work. But this has a bad effect on user experience, because then the user is just going to sit there looking at the screen for 60 seconds and not know what's going on. We should also provide error feedback to the user and redirect them to a screen where he can actually take some corrective action. Maybe a screen that says, we detected the timeout might be because you're in a slow network. Connect to a faster network and tap this button to retry. Something like that would be better than what we have right now. I don't have time to actually do any of those actions, but I think this was enough to make the point. So in conclusion, no data. This could mean an offline sync issue. You could start by simulating network conditions, either in Chrome or in your mobile device. You can connect your mobile device to 2G. If you don't have a SIM card, you can actually connect another mobile device where you do have a SIM card, connect that to 2G, and then create a hotspot where you connected the first device. You can trace the server request like we did to see what's taking a very long time. But remember, it's always best to instrument the app before launch. You should optimize your sync process for slow networks, and you should always invest in proper error handling in your app so that your user doesn't get frustrated with behaviors he doesn't understand. Okay, so I'm done with the demo. Just as a quick recap, I'd like to say that while troubleshooting is not an exact science, we all have our favorite methods and our particular specific thought processes, it is still a science. When troubleshooting, you need to stay methodical. You need to work to isolate the problem. Don't try too many things at once. Don't change 3 things and then you can't interpret the results. You don't know what had an effect on what. Test related scenarios. Once you have an idea of what might be going on, extrapolate and see if this was going on, then this would happen, and go test that. The process is mostly about collecting information. Instrumenting your app in advance is very good because it'll give you this information without you having to go post-fact at this collection. Know the underlying technology. This is very important because it'll guide you through the troubleshooting process. And finally, know the available tools and pick the best one for the job. Never underestimate code review and rubber ducking. These are really cheap, and a lot of times they solve the problem for you. Do check out these links. There's a lot of complementary information. And that's it from me. Thank you very much for attending, and I hope this was useful to you.